Hello, in this video I will talk about arrays and pointers. Let's write some array. So let's say we have an integer array and then let me say size is 3 and let me also initialize that. So I can say 6, 7, 8. Okay, so 3 elements. So if I want to display the value of a, I say so %d. Okay. So here let's say a 0. So the indexes goes from 0. So starts from 0. So this is index 0, 1, and 2. Okay. So if I just run it. Okay. So compile it and run it. Okay, it displays 6. So let me just copy and paste this several times. Okay, so here I will display second one and I will display the third one. Okay, so if I compile it, run it. Okay, so it displays 6, 7, 8. So how about the address locations? So let me say, let's use P for the pointers, P and P. And here, remember, address location is ampersand. So this displays the address location of these values, these elements. So if I compile it and run it, okay, so these are the address locations. As you see, the memory element, the array elements are stored in consecutive memory locations. So this is the address location. If you add 4, if you are good in the arithmetic in hexadecimal numbers, so this plus 4, so remember C, and then let's let's add 4. After C we have D, E, F, and then 0. Okay, so this becomes 0 and this is D. And also if you add 4, so this is the address location of the next one. Okay, so there is a purpose that I display the address locations because the name of the array also stores the address location of the first element. So if I say, let me just copy and paste. Okay, so address the A, not the address of A. Okay, so just the name of it, the name A stores the same. So this A has the same value as address location of the first element. So let me compile it and run it. Okay, if you see the first one and last one, they are the same. Okay, so this has the information of this. Now let's talk about the pointers. Let's say I want to store the value of this, which is this one, in a pointer. Okay, so that we can traverse in the array. So we can go from first element to second element, third element. So we can just traverse in the array. So here I will have a integer pointer. Okay, P, because the value of, so this first element is not a pointer. This first element is an integer which stores 6 in it. Okay, now I do this. I say, so P is pointer. I say P equals, okay, A. Now, or let me say PTR. Okay, PTR. So if I, let me just copy and paste it. So here, let me display what PTR has. Okay, compile it and run it. Okay, so PTR has the same value. Okay, you can do this. You can get the value of A and then assign it to PTR. But A is not a pointer. I'm sorry. A is actually it stores address location, but it is not variable. So you cannot change its value. So it is not variable. The value cannot be varied. Okay. So right now PTR and A has the same value, but we can change the value of the PTR, but we cannot change the value of the A. So you cannot do this. Okay, you cannot change it. But you can do this, PTR plus plus, because the value of the PTR variable can be changed. So if I do this, A equals PTR. So let me try to compile it. Okay, I got an error. It says this array is not, so this value is not assignable. Okay, so we cannot do this. So let me just delete this. Also, so print f. Okay, so let me just delete this one also. Okay, so print f %d. Okay. If I say a1, okay, so let me comment this out. Okay, so a1, so let me compile it. Okay, it displays 7. Okay, so 1 is the second element. Okay, it displays 7. I could also do this. So let me just copy and paste. Okay, instead of doing it, I could say, remember, A is an address location. And then I say +1, okay, and so this is also an address location. Actually, when I say 1, but because A is stores the integers and each integer consumes 4 bytes, so this will be basically whatever this is plus 4 bytes. Okay, and I will not display, so this should not be D. D is used for the integers. I don't want to display the address location. I want to display whatever we have, the value of it. So this is an address location. Let me put it in a parenthesis, and I say, okay, so let me put some space characters. So the thing pointed by this. Okay, so the thing pointed by this, and I will display it. Let me compile it and run it. Okay, as you see, we got the same value. So this, so let me just put here, this is the same as this. Okay, and similarly, this is the same as this one. Okay, so here, not surprisingly, if this is 0, so remember, A is the address location of the first character, so I'm sorry, first element. So this is also the same. So the thing pointed by this. Okay, so you can consider A as a pointer, but it is not variable. You cannot change its value. Okay, so by saying A plus 1, actually we are not changing the value of the A. So the value of the A remains the same in this way. So let me just compile this and run it. Okay, we got the same value. I hope this is clear. Have a nice day.